guys owe me homework, so again, if you have your homework, please go ahead and take it out. Make sure your first and last name is on it, along with the date. I'm gonna ask that you pass it all the way down to Kaylee, and Kaylee will put it in the basket. Yes, ma'am. Today is the 7th.
Do we need our calculator?
You will not need your calculators. Second thing that I want to draw your attention to in the back, you see the lovely accordion. I apologize, I've run out of copies of yesterday's stuff, but I will make sure that those get in there before the end of the day. I just making some more copies. Those are your makeup packets, so if you missed a day, come in yourself and get them. There's Monday and there'll be Tuesday. I actually write out the notes in there for you, so it's not just a blank packet. It should be very easy for you to follow through the notes and do your homework or anything that is due, okay? So at any point in time, if you need to grab one of those, please take it upon yourself to be able to get it. If it gets down to the last packet in there, instead of taking it, please let me know so I can make more copies of it. That way I don't have to re-handwrite things again.
So you haven't put it Tuesdays, because it's not.
No, Tuesday it just got taken up, so I'll get more of them in before the end of the day. All right, any questions? Nope, all right. Let's go into the do now. So, Quaylee, can you read number 1 for me, please? Shane, come sit down. All right. Don't walk in front of me. So, A is asking us if we have to write an equation, which is what we've done for the past 2 days. What's the very first step when we have to write an equation? Try it.
We gotta find out what our constant rate is.
Yes, we find our constant rate. What's the equation for constant rate, Trey?
D over T.
D over T, or distance
Or
over
Y
time.
over X.
Or Y over X. Very good. So in this particular equation, Shane, can you tell me what is my distance and what is my time?
Gallon,
Okay, so what's the number?
11/4.
So 11 over 4, okay? Now, we've got our constant rate. In order to write our equation, what do we need to set our constant rate equal to?
Y over X.
Y over X. So equals Y over X. Brandon, did you need something?
Yeah, can I go plug this in just a second, because I need to charge.
Oh, yeah.
We'll have to hold off.
I was literally, our computers hadn't been charged in 2 days. I literally was the one that took the switch on.
That's right, it's okay. Just hang on to it for now. We'll have to get it taken care of when
You
you
wanna
see it
use mine?
later.
I charged the map.
All right, so now we have our 11 over 4 equal to Y over X. Now what do we do? Yes, Shane.
Cross multiply.
Cross multiply, we get 4y equals 11x. Idris, what do I do next? So we want to get y by itself. So how do I do that? Divide by 4 on both sides, very good. So that leaves me with y equals 11 over 4x. Or the other way we can write that is y equals 2.75x. Okay, so there are both of our equations that we had to write. Kaylee, can you read part B for me, please?
No.
Use the equation you wrote in part A to determine the amount of water that flows from the hose during the 8-minute period, a 4-minute period, and a 2-minute period.
Awesome. So first thing it tells us, we're gonna use the equation from above. We've got this one, where it's written in a fraction, or we have this one where it's written in a decimal. I suggest using the one written in a decimal. It's just easier when you want to plug it into your calculator. So we're going to use that equation, and we need to plug in for the time frames that we have. 8 minutes, 4 minutes, and 2 minutes. Where am I going to plug those in at? For X, why X? Yes, Quaylee, because X is the minutes and represents the times. That's why we plug it in. So for the first one, Quaylee, can you walk me through it? Y equals what? Perfect. It equals 22. I got you, dear. No worries. So y equals 22. Okay? Who can do the second one for me? Give me a strong hand. Strong hand. Shane's the only one?
No, you just had Quaylee do it, so don't do that.
I don't feel confident.
What? Are you sure? All right. Come on, Shane. Give me what the second one.
Jeez.
So what's my equation going to be?
Y equals 2.75 times 4 equals 11.
Yes. So y equals 11. Very good. And then what about the last one? Who can plug things in for the last one? Someone I haven't heard from.
You haven't heard from my right hand.
Nanny, what you got?
I got you, 2.75 times 2 equals 5.5.
Thank you, Shane. So y equals 5.5.
No,
So
Miss
remember,
Nine.
like we talked about yesterday, when we did this yesterday in the example, we've got our coordinates. So this is our x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate. So go ahead and take 3 seconds, make sure you have all of this written down. I'm gonna scroll down so we can get down to part C. No, it's called gingerbread. Maybe, we'll see
I could
later.
have sworn it was 56 or 57 degrees yesterday.
I know, and now we have snow. Welcome to Ohio, Trey.
Oh no, I was forecasting it most of the night.
Awesome.
I
So,
don't know.
An
No
input,
school.
all right, Trey, can you come back now? Thank you. An input of the function x is time in minutes, and the output of the function y, Shane, is the amount of water that flows out of the hose in gallons. Write the inputs and outputs for part B as ordered pairs and plot them as points on the coordinate plane. So point B, go ahead, Dave. Point B, remember we went through and saw through, and I showed you where we had our coordinates. So the first one was 8, 22. Who can tell me the second one? What's the second set of coordinates? Yes, Whaley. 4, 11. Shane, you got me for the last one?
2, 5.5.
Perfect. Now, I apologize, I know you can't see these very well, okay?
I can't.
So, the x-axis right here is numbered by ones,
Okay, 2.
and then the y-axis is numbered by twos, okay? So our first one, 8, 22, so 1, 2, 3, 4, 5, 6, 7, 8. We're basically gonna go all the way up here to the top where it says 22, and we'll make our, excuse me, our first dot there. Our second one is at 4 and 11. So 1, 2, 3, 4, 2, 4, 6, 8,
Go up one more.
10, and we're gonna go halfway in between the 10 and the 12. And that's where our second dot will go.
Can I do the next one? Let me do the next one.
Okay, tell me, guide me to it, Shane.
You go over 2,
1, 2,
and you go up, well, 1 basically, which would be 2. Then you
2.
go up another one, which would be 4, and then you go in between them. Hold on, wait. You go between it and then up.
yeah. So in between would be 5, and then in between that and 6 would be the 5.5. Perfect, Shane.
Thank you. I'm on a good.
So your graph, your plotting should look very similar to that. So does anyone have any questions? It's the recap of yesterday.
What's
Well, I think Lee did a great job on yesterday, so this should be easy.
Awesome. High five. Thank you.
If I go around.
Well, stay there though.
I know.
All right. All right. All right, guys, so what we're doing today is we're gonna look at 2 different functions represented 2 different ways, and then we're gonna be able to see that we can compare those functions, okay? So for this particular problem, we've got the following table and graph represents 2 different linear functions, determine which has a greater rate of change. So this table is one function, this graph is a second function, okay? So in order to determine the rate of change for the table, and I'm gonna scroll this down a little bit just so we don't have to do it in a minute. Okay, so we need to determine the rate of change from the table, okay? If you need to, underline tables so that you know what we're doing here, this work is affiliated with this table. So the way that we're gonna do, we're gonna use this formula, which is change of y values over change of x values. So all that means is I'm going to take this y minus this y. All of that is going over this x minus this x, okay? So, yep, -2 minus -3, perfect, Kaylee, over -2 minus -4. So now let's walk through how this looks. Negative 2 minus the negative 3 is the same thing as saying negative 2 plus a positive 3, and what do we get? No, negative 2 plus a positive 3. Not negative, but 1. So positive 1 over, same thing, negative 2 minus negative 4, same thing as saying negative 2 plus a positive 4. What do we get? 2. Now, here's the big question. What does this 1/2 actually represent? What does it mean? Say it one more time for me. Yes, it represents the rate of change of the table. So what I want you guys to make sure you're doing is labeling everything, okay? So I'm gonna label this. Rate of change, Shane, for the table. Okay, that's gonna help me later. Now we need to determine the rate of change for the graph. So you can underline that as well so we know we're dealing with the graph. When you're looking for the rate of change for the graph, it's the same thing as saying that you need to identify the slope. Who can remind me of the 2 ways that we can find slope? What are the 2 ways we can find slope? Trey, give me one.
Y equals mx plus b.
That's slope-intercept form, but how do we find?
Y2 minus y1
Yes.
over x.
So m equals y2 minus y1 over x2 minus x1. Quayla, can you give me a second one? So I know you have your hand up here. Do you remember the other one? Rise over run. Awesome. Now, which one did I tell you guys was easier to do when you're given a picture of the graph? Rise over run, right?
Yeah.
So, we have a point right here on the graph, which is 0, negative 4. If I could write, that'd be great. And then we have a point that's right about here on the graph, Shane, which is 6, 2, okay? So then I have my rise and my run.
Wait, what you said? Do the one that come first. You did 6-2, and that don't come first. You bring it left to right.
No, I said 0, negative 4. That's this one. And then the next one is 6, 2.
What am I talking?
It's okay. You're fine. All right, so you guys remember on your do nows in Miss Cook's class, and there's a pretty wordy problem in that do now that asks for you to determine what happens to a coordinate when it is reflected, rotated, translates, etc. Okay?
Well, those are my favorite.
Right. So you're gonna be good at this, right?
Yes.
So this is where this comes in handy. Negative 4 to 2. What did I do? I went up how many?
You went up, wait, 4 to 2?
Negative 4 to 2.
Oh, that's 6.
6. Great. Now I slid or I translated to the right. How many? 0 to 6.
6.
6. So now down here, I know I'm doing my rise over my run.
6 over 6.
Plug it in. That's right, Shane. 6 over 6. What does that
1.
simplify down to? 1. Now I'm going to ask the reverse question. What does this 1 actually mean? What is it telling me?
Slope.
It's the what? Well, yes, it is the slope, but what did we have to find?
The rate of change.
The rate of change for the what?
Table.
Graph.
Graph.
For the graph.
Oh, I thought we were on the first one.
That's okay, so just label it, okay? This is the rate of change for the graph.
I just realized the first one and the second one are the same question, just switched that. And I was gonna do the first one. I started with the table.
That's okay, so you're right. Both of the questions are asking for the same thing, which is the rate of change. But we have to do them separately because we have a table and we have a graph. So there's 2 different ways to find the rate of change based off we're using a table or a graph.
And those numbers that's on the table is not, so it's hard to know. Alright, so the graph coordinates, they're not a coordinate without a table.
So it's not the same, right? There's 2 separate functions. So are you asking the coordinates on the graph, are they gonna be the same numbers that are gonna be on the table? Is that what you're asking?
Yeah, with skip, would you have to verify?
No, they're not going to be. And the reason why is because, let's say for instance, this is function A and this is function B. So they're 2 different functions. It's not the same function. If we were to have the coordinates here written in this table, then it would be function A and function A, just written 2 different ways. These are 2 separate functions. Make sense now?
Yes.
So now we're gonna compare. That's why you have
Yes.
2 different rates of change. Make sense?
Yes, sir.
Okay. Can I go ahead and erase?
Yep.
All right,
Go ahead and go
go
down.
down, please.
Go ahead, go down.
Yes, you can scroll down for me, thank you.
Stuff like that.
So now we need to compare those constant rates of change. So what was my constant rate of change for the table?
1/2.
1/2. What was my constant rate of change for the graph?
1.
1. Which one's larger?
One.
Graph.
Or the graph, okay? So now the key is, again, this is a word problem, so make sure you write your sentence. So I would say, the graph, if I could write, has a greater rate of change. So the graph has a greater rate of change. Quietly come back. Open your eyes. Alright, so take about another 3 seconds to get this written down, and we're gonna move on to the next one. Let me check, where's our time?
Oh, we got 20. 21.
So what, it's 10:21?
10:41. Or 10:41.
No, 10:21 is when you guys pack up, okay.
At
No,
10:21, what is
wait.
it?
I'm sorry, 11:01. I'm sorry, guys. 11:01. Shane, calm down, sweetie. Calm down. Calm down. Alright, you ready? So let's move into the second problem. This one is the same exact concept, but we're gonna add a few extra steps to it, okay? So we're gonna build on what we just did. So let's see, who can read that top paragraph for me? Thank you, Neil.
The function that gives the volume of water that flows from faucet A in gallons from X minutes to 20 minutes.
Shane.
Function with the subtraction. Faucet C's water flow can be described by equation y equals 5/6x, where y is the volume of water in gallons that flows from the faucet during X minutes. Assume the flow of water from each faucet is constant. Each faucet has a faster rate of flow of water. Each faucet is being used to fill itself with the volume of 50 gallons. How long will it take each faucet to fill its tub? How do we know?
Awesome, okay. So we've got two different functions. Faucet A, faucet B. One is represented as an equation, the other one is represented as a graph. Which one is represented as the equation?
The one that's from that equation of y equals 5/6x.
Right, so which one is that? Which one is the equation?
B.
Faucet B, very good. So this is faucet B. So then which one's represented as the graph? Trey, what you think?
I think that the one represented for the graph is the like 5, 6x.
Right, so faucet B represents the equation. So is it faucet A or faucet B that represents the graph?
Faucet A.
Faucet A, okay? Again, I'm labeling everything because these are word problems. It makes it easier when you have labels and stuff so your eye can quickly see what you need to know. So the first question is, the first thing is that we have to assume they have a constant rate, okay? Then the next question is which faucet has a faster rate of flow? This one's represented as an equation already, so can we readily and easily identify our constant rate?
Yes.
Yes, what is our constant rate, Haley?
5/6.
5/6, awesome. So this is what I'm gonna do, I apologize, I've got less working space than you, so I'm gonna scroll down. Just gonna put my phone down, please. Thank you. Alright, so I have faucet B, faucet B. And my equation for faucet B is y equals 5/6 x. And then I know, because Haley just told me that 5/6 represents my constant, or my constant rate. Okay?
I told you that.
So now, I need to find my constant rate for faucet A, which is here. How do I find the constant rate for faucet A? What do I need to do?
Distance over time per gallon over.
So look at the page before and see what did we do to
I would
determine
not
for
like
a
making
graph.
a
Find
function
the
table.
slope.
Find the slope, okay? So I've got a point here, and I have a point here. What am I gonna use to find my slope? Rise over run. So I go up, I go over. So how many did I go up, guys? Quayle, how many did I go up? Say it one more time. So look here what they're labeled.
Well, I should say.
So look a little closer. 4. So I went up 4. Trey, how many did I go over?
7.
7. So what's my rise over run?
4 over 7.
4 over 7. Okay. If I want to go ahead and write that as an equation, so that I have an equation here and I have an equation there, what do I need to do that 4 over 7?
That's what.
Not
Or
necessarily
y
decimal.
equals 4/7 x.
That's what it'll ultimately end up being, but how do I go through the whole process? I set that equal to what?
Oh, then supposed to be.
Water.
Y over x.
Oh, God.
I know, I'm asking you guys to mix a whole bunch of stuff together. Then what do I do at this point? Idris, what do I do at this point? You know he's so helpful, isn't he? 7y equals 4x. Shane, what's the last thing I need to do? Divide what? By what? Or to what?
4,
Thank you.
which gives me y equals 4/7 x.
So now we have y equals 4/7 x. Okay, so I've got here, here. We know that this 4/7 represents what?
Constant rate.
The constant rate. Kaylee, you are on fire today, dude. Seriously.
I'm on fire.
I got some water to put her out.
I don't
Okay.
want her put out. I'm enjoying her being on fire, so leave her that way, Trey.
What is the point of doing this whole setting equal to y over x if it's gonna be the same thing?
Because in the end, we want to basically be able to see 2 different equations.
Okay.
So one of the positives when you're dealing with functions, do you necessarily have to do it? No, but it's helpful when you have all these different processes and steps that you have to go to. That if I can go back and see, these are my 2 equations, which I can tell you you're gonna need both these equations again, because there's still more stuff we have to do. So that's where it helps to make it a little bit easier for you. So we've got a constant rate of 5 over 6 and a constant rate of 4 over 7. Now we need to compare those constant rates, right? So we've got 5 over 6 and 4 over 7. Which one's larger? There's 2 ways you can look at it. So
5
let's
over
get started.
6.
You're right, 5 over 6 is larger.
5 over 6 is like 83%. 4 over 7 is less than 83%.
How did you come up with that so quickly?
Cause Trey is Trey. He literally does it. in the
Dude,
tape.
that's like off the chain. For real. Alright, so Trey is right. 5 over 6 is larger than 4 over 7. He's also right that 5 over 6 ends up being about 83% or 0.83 if you were to turn it into a decimal. And 4 over 7 ends up being about 57% or 0.57 if you turn it into a decimal. Okay, so he's right. Now, we need to write a sentence though to describe this. So what would we write as our sentence? Quayle, wake up, sweetie. Oh. You gonna try this? Alright,
Yeah.
try. Okay, what is it?
Faucet B is like filling up more than faucet A.
So we're asking for the constant rate.
Oh,
Which
the
one has
faucet
the greater?
A has faucet B has a greater constant rate than faucet A because faucet B has a constant rate of 0.833. And faucet B has a constant rate of 0.57.
No homework. No more
Beyond,
homework.
above and beyond. So what he said is correct. Basically, all you had to say is that, I can't spell today, I'm sorry guys. Faucet B has a greater constant rate than faucet A. That's all you have to say, okay? Make sure you guys are writing those sentences though to actually answer the question because these are word problems. So there's still more that we need to do because there's a second part up in that first paragraph. So make sure you guys get all this written down. I'm gonna go ahead and erase it so we can do that second part so I don't have as much workspace as you. So go ahead and take about another 3 seconds. Quayle, wake up, sweetie. Alright, I'm gonna go ahead and erase. Alright, so the second part is, each faucet is being used to fill a tub within a volume of 50 gallons. Alright, so remember you asked earlier with regards to the equations, this is where we're gonna really need those equations again. So we have faucet A, and faucet A equation was what?
What's that?
Yep, so y equals 4 over 7x, and then we have faucet B. And what is faucet B's equation?
5, 6.
So y equals 5 over 6x. Now, we have this 50-gallon tub. Wait, Bailey, do you need to stand up, or do you need to like walk around a little bit? Okay, we gotta keep your eyes open, please. So So we have this 50-gallon tub, so it's a 50-gallon max. What am I gonna plug my 50 in for? Am I gonna plug it in for Y or for X?
Well, why?
Why, Trey?
Why? Because it's the output. Like, we're basically gonna make that, like, 50 is gonna be an output, not, like, you're not putting 50, like, into the thing, because that's the maximum amount.
Right, so what Trey's trying to explain is that 50 is the max, it's our output. Like when you have a tub, if we go more than 50, what's gonna happen to the
It's
water?
gonna overflow.
It's gonna
It's
overflow.
gonna be a flood here.
It's gonna be a flood, right? So the max that we can do is 50, so that's like your maximum output, and we know that Y represents your output. We also know, what else does Y represent? So if you're thinking about distance over time, what else does Y represent? Quayle, that would be X. The actual tub or the distance, like the gallons, yep. So just know, like, when you're talking about like the water gallons and distance, that like that word can kind of go a little bit interchangeable when it comes to the Y. Go quickly here. All right, so we're gonna plug our 50 in for Y. So then it gives us 50 equals, what did we say? 4/7 was 0.57? Yeah, 0.57x. So now what do we need to do in order to solve for x? Shane,
We have to do whatever we keep doing.
Shane, put my phone back, please, and stop messing with my phone. And then look up here, please. So close my phone out.
You better not be messing up for Uno with friends.
And then Shane, what do I need to do? Look what I have there. I've got 50 equals 0.57x.
Set it equal.
So I've got 50 equals 0.57x. What do I need to do to solve for x? Divide by what?
0.57.
Okay, perfect. Divide by 0.57 on both sides.
I have no idea what you're doing.
That's okay, I've got it. It ends up being 87.7 equals x. Now, what does that 87.7 actually represent? What does that mean?
It's like for B, right, isn't it?
What's for A,
Oh wait,
but what does this mean?
it means like how fast it go up.
Yep, so how long? So how long will it take for faucet A to fill up that 50-gallon tub?
7.7 minutes. Oh wait, 88 minutes.
So you can say either 87.7 minutes, or you can say between 87 and 88 minutes. You guys are both correct, you and Kaylee are both correct. So now, we're gonna do the same thing for faucet B, because we need to be able to compare these in the end. So for my faucet B, where am I gonna plug the 50 in? Idris, you got me? Where am I plugging 50 in at? So am I plugging in for Y or for X? For Y, that's right. So 50 equals, and then 5 divided by 6 is 0.83x. So now what do I need to do in order to solve for x? Manny, what do I need to do?
Divide 0.83.
Okay, and then 50 divided by 0.83 is 60.2 equals x. What does that 60.2 mean? Yes. Hold on, someone other than Trey. I know you got me, but Kaylee, what do you think?
60, it takes 60.2 minutes
To fill up that 50-gallon tub, okay? The last part we need to do, who can read these two lines underneath the graph for me? Trey, go ahead.
Alright, thank you.
You're
Suppose the tub being filled by faucet A, 115 gallons of water into it, in it. And the tub being filled by faucet B started empty. Now both faucets are turned on at the same time. Which faucet can fill the tub fastest?
Okay, so which one filled the fastest? So it already says faucet A is starting with 15 gallons. Faucet B is starting at empty. So do we need to do any more work for faucet B?
No,
Why?
because
Because
it's
it's the
max.
same thing all the time.
One change.
Well, not that it's max, but the key is, where is faucet B starting at?
0.
Starting at 0. How do we know, Trey, that this one right here is starting at 0?
Because it says it, it's starting empty.
Yep, it says it here, it says it up there, but look at the equation. What about the equation tells us that it's starting at 0?
Why? Why would have a number to it?
The y-intercept part, or there would be something here, right? We would have that starting point. So we don't have it here, so we know that B is starting where?
0.
0, very good. So now A, we maybe need to add something to it. So we have faucet A, and the faucet A equation is y equals 4/7x. What do I need to do to this equation to represent the 15 gallons that faucet A is starting at? Multiply?
Said why?
When you have to start put a starting point
15
on the
equals 4.
equation?
Okay, hold on. So Trey,
What?
Don't you have to put a starting point on the equation now?
and where does the starting point go on the equation?
15,
But where does it go on the equation? Like how would
on the
I?
y.
It goes where what the y-intercept would go on the
Yeah,
slope-intercept point?
y-intercept.
So how would I write it here? What do I need to physically write? Tell me what.
Plus 15.
Plus 15. Okay? Remember yesterday and the day before when we talked about this equation, what this part represents? What does this part represent?
Your starting point.
Your starting point, okay? So anytime where you have something added up here and it gives a different starting point other than 0, you just add it right there. Okay,
Wow.
so plus 15. So now, I gotta plug my 50 back in. Where does my 50 go? Someone besides Trey.
Why?
Y, thank you. So then it's 50, and we're gonna go ahead and use that decimal again, which is 0.57 x plus 15. What do I do?
You would subtract 15 from both sides.
Subtract 15 from both sides. 50 minus 15 is what? You got me, Trey?
Yeah, 35.
35.
I said it first.
I know, but I
what
did
is your
call
name,
it Trey. Equals 0.57x. Now what do I do, Shane?
You divide
Divide what?
0.57
Okay,
from both sides.
thank you. I apologize, I'm running out of space, guys, so divided by 0.57, divided by 0.57, and I get 35 divided by 0.57. Let me move this really fast.
35 divided.
Which gives me 61.4 equals x.
I was way off what I thought it was.
That's okay. So now what do we need to compare? What are we comparing?
Your faucet A and B.
So new faucet A with the old faucet B. Which one is gonna fill up the 50 gallon
Faucet A.
tub faster?
Faucet A.
Faucet A at 61.4. It's gonna take 61 minutes to fill up faucet A.
Oh, no.
Idris, what do you think?
Faucet B,
Faucet B, why?
because
Hold on, Trey.
it's one. It's,
If I get another one wrong.
That's perfect. Can everyone stop talking so you guys can actually hear what Idris says, please? Can you repeat it one more time for me, dear?
because faucet B has one number less than faucet A.
Because faucet B has one number less, or it takes 1 minute less to fill up than faucet A. So he is correct. That is awesome. All right, so I
didn't do nothing. I actually have all the work too, though.
that's great, sweetie. I'm so happy. All right,
We have
so I
4
have,
minutes.
listen please, I have good news and I have bad news. Which one do you want first?
Bad news.
Bad news.
Yes, they're all the same. So, the bad news is, Miss Estis made a hiccup when she was copying and putting your packets